All right, today we're going to crack the code on one of the most common, yet, let's be honest, kind of mysterious little parts in all of electronics, the resistor. You've seen them. They're tiny, they're covered in colorful stripes, and they are absolutely everywhere.
So, what is the deal with these little bands of color? Are they just for decoration? No way. They're actually a code, hiding a really crucial piece of information right there in plain sight. And in the next few minutes, you and I are going to crack that code together. So let's start with the basics. These tiny components, they might seem insignificant, but trust me, they are the silent workhorses of pretty much every circuit board out there. Seriously, if you've ever popped open a TV remote, a computer, or even one of those talking birthday cards, you've seen tons of these. They're called resistors, and their whole job is to control the flow of electricity. But for them to do that job right, you have to know their value. And yep, that value is hidden in that colorful code. Okay, so how do we turn those colors into actual numbers? It might look kind of random, but these stripes follow a standardized international system. And the best part is, once you learn it, you can read any resistor you ever come across. First things first, which way do we even read this thing? Well, you read them from left to right, and the trick is to find the side with the bigger gap. See how there's a larger space between that third and fourth band? That last band, the one that's kind of hanging out on its own, that's always on the right. On a typical 4-band resistor, each band has a very specific job. The first 2 bands, they give you the first 2 digits of the resistor's value. That third band is the multiplier. It basically tells you how many zeros to add at the end. And that fourth band, that one's called the tolerance, and it tells you how precise the component's value really is. So you know what the bands do, but what do the actual colors mean? For that, my friend, we need the master key to the entire system. And here it is. This chart is your official decoder ring. You can see how each color, from black to white, corresponds to a number from 0 to 9 for those first 2 bands. Then, that same color represents a multiplier in the third spot. And finally, you have colors like gold and silver that represent a tolerance value in that last position. All right, theory is great and all, but the best way to really get this is to just do it. So, let's take a real-world example and decode it together, step by step. We're going to work with a super common resistor, one that has 4 bands: yellow, violet, red, and then that gold band off to the right. Okay, let's break it down. Band 1 is yellow. We look at our master chart, find yellow in that significant figures column, and boom, it's the number 4. That's our first digit. Simple as that. Next up, the second band is violet. Back to the chart we go. Violet gives us our second digit, which is the number 7. So far, we've got the digits 4 and 7. And now for band 3, our multiplier. In this case, it's red. The chart tells us a red multiplier means we multiply by 10 to the power of 2, or, to put it simply, by 100. This band just tells us how many zeros to tack on to our first 2 numbers. So, let's put it all together. We take our first 2 digits, 4 and 7, which makes the number 47. Then we apply our red multiplier, which is times 100. And that gives us our answer. 47 times 100 is 4,700. The unit for electrical resistance is the ohm, so this is a 4,700 ohm resistor. See, we cracked the code. But hold on, we're not quite done. What about that last gold band? That's the tolerance. Gold means a tolerance of plus or minus 5%. All this means is that the manufacturer guarantees the resistor's actual value is within 5% of 4,700 ohms. It's really just a measure of the component's precision. So now that you've totally mastered the common 4-band resistor, you should know there are a few other variations out there, usually for more specialized jobs. For instance, you might see high-precision resistors that use a 5-band system. That's for a third significant digit. A 6-band system adds another stripe for something called the temperature coefficient, which just tells you how much the resistance might change when it gets hot or cold. There are even special military codes, and one particularly clever variation. The 0-ohm resistor. It's exactly what it sounds like, a resistor with 0 resistance, and it's marked with just a single black band. It's basically a wire disguised as a resistor. So why would this even exist? Well, it's a brilliantly simple hack for manufacturing. It lets the same automated machines that place all the other resistors also place these little jumper wires on a circuit board, which saves a ton of time and money. Pretty smart, right? So, After all that, why should you care about reading tiny stripes on a tiny component? What's the real takeaway here? Well, this isn't just some quirky color system, it's the universal language of electronics. Being able to read this code means you can look at a circuit board and actually understand what's going on. It's the very first step to fixing a broken device or even building your own electronic projects from scratch.
I mean, think about it. In just a few minutes, you've transformed what looks like a cryptic, random symbol into valuable, practical information. You went from seeing a bunch of colors to seeing real data. You now have the key.
And that brings us to the final thought. This knowledge, it's a tool, and it's now yours to use. So the real question is this. Now that you can read the code, now that you speak the language, what will you build? What will you fix? The next step is all yours. Thanks for joining me.